Now, steady states or equilibrium solution is actually a rather simple concept. I promise you we will do lots of complicated stuff, but steady states and equilibria are actually one of the simpler concepts. It just means a solution does not depend on time. So here, for example, if I have a solution u of x and t, if it does not depend on time, I call this u bar of x. So we have one variable less to worry about. Okay, let's look at this for the heat equation with boundary conditions and initial condition. So this is the heat equation. These are two boundary conditions. And this is one initial condition. If you look at the rule of thumb, right, you won't have to have one side condition for time, which is the initial condition here, and you want to have two conditions, two side conditions for space, which are the two boundary conditions. So the number of conditions is correct. Now let's look at the steady state or the equilibrium of this PDE. Okay, steady state equilibrium means it does not depend on time, so the time derivative is 0. That's what it means. Going back to the equation here, this means the ut thing is 0. So what we keep is d times uxx is equal to 0. So I hope that shows up here somewhere. And then the factor d, which would be in front, we can actually remove because the second derivative has to be equal to 0. And here there should be a bar. So u bar x is 0. This also means basically you can read this as u bar prime prime is 0. But then we can easily solve it, right? So then u prime or u bar prime is a constant, a. So that's actually what's happening here. And we can integrate this once more. So then u bar would be ax plus b. It is really as simple as that. You just integrate once with respect to x. And then you integrate once more. But now we have the two side conditions. We had two side conditions for the boundary. The concentration is either C1 at x is 0 or C2 at x is L. So let's use that. So at x is 0, we are given the concentration C1, but if we sub in this function here and sub in x is 0, then we just keep the b. So this means b is C1. Okay, so we found already one of the constants, and maybe from the other side condition we can find the other constant. Let's do that. So here at x is L, we had the side condition C2. And now taking the function from upstairs, evaluated at x is L, we get AL plus C1. And from this we should be able to find A, right? And we can. So then A is C2 minus C1 divided by L. Right, so we get AL is then C2 minus C1, and then we divide this by L, and we get A. Okay, going back to the earlier solution, we had u bar of x is ax plus b, and we now know what a and b is, so we can just sub it in, and we get this guy here. C2 minus C1 divided by Lx plus C1.